Okay, let me see. Let me put it on the chat itself. I'm not very sure how it functions actually. Okay, so I can do one thing now. We can answer how many of you felt the epsilon delta definition of limits is of no use. Okay. So how many of you felt means that you're going to answer only if that you felt it is not right actually. Yeah. So you can chat. You can write an answer. So I could see it's a 8-3. So there are the 2, 3, 4, 5, 7, 8, 9, 10, 11, 12, 13, 14, 17. But only one student X77 says that it's very useful. Okay, no use. Yes means to say that it's not useful, right? Homoeopathy is not useful, right? Yes, go ahead. So it is understood, it's given because it is useful, but have you felt? I mean, it is your understanding. I guess useful, that's okay. Now, be precise in answering because you already studied it. It's not some arbitrary, question that I'm posing it. Think about it. You can give a, valid answer actually. So what I could see that now it is 8-5. Out of 95 students, only 76 have joined actually. So can I know any reasons? Is there any communication happening between you and your friends? Shreya? X27. Shreya?
Yes, sir.
Is there any issue with another students? Are there any asking any questions to you?
No, sir. No one didn't tell it.
Class link. Okay. Fine, because I could see anyway. So today I'll keep minimal in discussion so that everybody should understand that we have started our classes. If I'm not wrong, today is the first day of your classes, the start of the classes. Am I right?
Yes, sir.
So I could say that there are only very few who say that it's actually useful, and I like one of the answer. I guess useful, obviously, and there should be some use. That's why it's might be given is like once again. Can I see I got a couple of answers. It's a useful actually. So in what sense you felt it is useful? For example, Shubham.
Yes, sir.
How do you felt like it is useful?
Yes, sir. Sir, अपने लोग ना टू फंक्शन ऑफ टू वेरिएबल पढ़ते हैं सर. टू फ्री वेरिएबल होती है सर. जेड इक्वल्स टू एफ ऑफ एक्स वाई लाइक ना. तो वन वेरिएबल में तो ठीक था कि वो लिमिट अपना डालते थे सर. वो पुट करते थे वैल्यू अपने डिटरमिनेट या इनडिटरमिनेट फॉर्म में आती थी तो हम सॉल्यूशन करते थे. लेकिन टू इनपुट फ्री वेरिएबल में क्या होती है ना कि इनफाइनाइट पाथ होती है सर किसी एक लिमिट पे पहुंचने के लिए. तो इनफाइनाइट पाथ में से हम कैसे कर सकते हैं तो 2-3 ट्राई तो कर सकते हैं किसी पाथ को लेकर, x इक्वल्स टू 1, x इक्वल्स टू 2, y इक्वल्स टू x, y इक्वल्स टू mx, लाइक y इक्वल्स टू mx स्क्वायर लाइक दैट, बट वो कंफर्म नहीं कि हम लोग उस पास से जा रहे हैं, किसी से आएगा किसी से नहीं आएगा। तो उस कंडीशन पे हम लोग ये एप्सिलॉन डेल्टा डेफिनेशन यूज करते हैं, वो हमेशा आंसर सही ही देती है, इसलिए एप्सिलॉन डेल्टा का बहुत यूजफुल है सर। कंटिन्यूटी डिफरेंशिएबिलिटी हर जगह पे जहाँ पे लिमिट आए वहाँ पे वो एप्सिलॉन डेल्टा इज वेरी यूजफुल।
इतना सा कहाँ से जानते हो? पढ़ा हो क्या? पहले से पढ़े हो क्या इसको?
नहीं, हाँ वो थोड़ा सा थ्योरी पढ़ा हो सर।
अच्छा अच्छा, ग्रेट, दैट्स वेरी गुड, वेरी गुड, ओके, ग्रेट, वेरी गुड. Acha, Praveen says just a hardcore mathematical way to define a limit, but of no use actually. So let me tell you, actually, not many people appreciate the subject as a mathematics. The reason being is that it is basically a very abstract, the subject is very abstract actually. So people has, the habit of, not straining them much actually. So some people grasp and some people doesn't grasp it actually. And that leads to, complications in the later stages. Like, at this particular stage, you're feeling it as a very complex. But it's not a complex. I would not, even blame you people. It is the way the mathematics have been taught from the school days. I mean, like, it's they put it as a problem solving, the mathematics remains as a problem solving. But if you carefully look at it, it is not the case actually. Okay. Where there is an understanding situation is there, the understanding has completely gone actually. Like, for example, this is the definition itself actually. Let us understand this definition. What is really we're doing with respect to your epsilon delta? Okay, what I mean to say understanding over here is the sense is that I'll just give you the, the notion. Let us understand what you do up to your 10 plus 12. You have studied limit differentiability in your previous classes also. But now what we're trying to do is that we are just added a couple of more things to it actually. Just a minute, huh? Okay. So I'll be using this OneNote tool for writing purpose. I'll be sharing this content, whatever I'm writing over here, that I'll be sharing with you. This notes is shared with you. This is stored on online actually. So you can access it at any time actually. Okay. So do not worry about copying whatever I'm writing it, but keep a concentration on, scribbling something which I'm trying to say. Sometimes I say something, but I may not be writing there. Okay, so that particular part you have to catch it up, and the rest of the notes you can prepare yourself later stage. And because this notes is already available, and I have shared a textbook on Google Classroom, so that is what the textbook I'm gonna use it for your, that's useful to connect yourself with the things that what I'm doing actually. Okay, you can connect there. So I hope I got one more answer also. Great. In epsilon delta method, we know that the limit exists at that particular point, but why do we prove it again, sir? Yes, Satya. So, like, definition means a definition, but that is not. But one thing, okay, everyone try to understand certain points actually. When we say definition means to say that it is a definition, but it is not to solve the problems using the definition. Not every problem can be solved by the definition, in a sense of there lies, the fundamental aspect of the definition is not implementable for every problem actually, but you need to get to the essence of the definition. We need to prove the essence of the definition. What it is saying is that definition is saying is that under what condition that is going to be that particular quantity, let's say L, I'm saying it actually, is going to be the limit for the function. See, what is happening, you have studied earlier, is that we are saying that L is your limit of f. Whenever say but let's say f is your scalar function, f from your, say, some subset of R to R, or some subset of R to R, R to R, at say x is equals to a point actually. What we're trying to say over here is that we're trying to say is that f of x is tending to L as your x is tending to a. Am I right? That's what is your definition. But this is an elementary way of looking at the actual epsilon delta definition, because this is easy to think about the definition. Actual definition is, what is an actual definition is? For every epsilon, because in your school days, this is going to be a tougher one, so we go the easiest way actually. For every epsilon greater than 0, there exists delta. That means to say that epsilon is the one which is, okay, that means to say that for delta that we're trying to find, it depends on epsilon. Given an epsilon, you're trying to find a delta actually. So there exists a delta greater than 0, such that what is happening? What is happening here? F of x minus L is less than epsilon whenever we have mod of x minus a is less than delta. Okay. Anybody has worried what is the values of epsilon and delta are? What I mean to say that? What are the values of epsilon and delta are? Have you ever asked yourself?
So there are some values in the domain near about x.
Yeah, what values actually? Integers, okay. So is it a 1, 2, 3 or so, or anything else actually? Have you realized this, what these numbers are actually? Yeah. Can be 0 also, positive real numbers. But what is the nature of these numbers are actually? Yeah, real numbers, very well. Yeah. That means to say that they are, in this particular definition, a small is a relative word. These are very small number. Very small number means to say that near to 0 or equivalent to 0. Equivalent to 0. What is an equivalent to 0 is that this is actually matters a variation vary. For example, what I mean to say that the difference between these two numbers, I want to have a 10 to the power of minus 3. Positive rational numbers, not very sure. So, okay. So now, so they are very small numbers that we're looking for. See, what we're saying, if this distance is going to be, I'm looking for epsilon given, that means to say that the difference between is going to be almost 0. If you can find such an epsilon, you should find a corresponding domain also. A set of points on a corresponding domain, which will give rise to this difference. That is what your definition is. What you studied in your elementary class, so that this laborious job is reduced to not a laborious job, but this is a preciseness actually. What is the underlying quantity that you're looking for is, for example, what do you mean by this symbol actually? Meaningless symbol. It's a symbol, but doesn't have any meaning actually, right? Symbols with no understanding. where there is no understanding, no precise understanding. Okay, tends to, that's a symbol actually that we are saying that this is approaching to this one. But approach is the one which we are trying to say is to be more precise. What do you mean an approach actually? That means to say that in a way, so there is no precise understanding in the sense you don't see in a real line, as Subarna has answered you, because you are sitting on a single line. You are sitting on a single line. So let me say this is a x and this is y. Y is equal to f of x. That is I'm looking. So I'm just looking at two values on a single line. Your f of x is approaching to L. I'm trying to say it actually. Okay, on a single line, this may make sense actually, but look at the functions in a two-dimensional functions actually. So this is your the two-dimensional function can be visualized in 3 dimensions, right? So we have x and we have a y and we have a z actually. Now given z is equals to say f of xy. So we have some function over here. So when I'm saying that f of x is tending to somewhere, this is having a point at some point. And this is tending to L. What does it mean tending to over here actually? Is this way it is going over here, or is this way it is going over here, or this way it is going over here? What do you mean by it's tending? Means it approaching to that one. So see that because you do not have any other alternative to approach, this made a sense to you. But whereas look at this particular scenario, I can approach the way I want to do it. And I have multiple choices to reach to this particular point. No, so how do I really now does it this approach making a sense to me? So I can reach to this particular point, I can reach to this particular point, I can reach to this particular point, and I can even go all along the way and come back to this particular point. Okay, I can even go triangular way, in a reverse order I can go. So see that means to say there was no precise understanding means that okay, here it is makes sense, but that in general doesn't make sense. Why we are leaving only with respect to one variable? We doesn't have that scenario, right? We may have another scenarios also. So what is happening in this whole process is that if you carefully look at it, what we're trying to say in this definition is that look at what is happening. F of x is tending to L as your x is tending to, as we say that no. As x is tending to L, f of x will be so can I write this one as f of x minus L is tending to 0 and x minus L is tending to 0? Can I write it up? But look at this is to be understood. Now we say that you may have a right. Sorry, this is extending to a. So you say that limit extending to a plus, limit extending to a minus, and blah 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 things, right? So from left side I approach and from right side also I approach. Then this should going to happen actually, right? So what is happening to understand that particular point in more precise that I'm looking for is this one, and the more precise, this is what I'm looking for it actually. This definition is universal actually in the sense of that I'm looking at as measure actually, and this symbol has to be removed, and this symbol has been removed by because this 0 is not same as this 0 actually, right? So the zeros has been replaced by your so-called epsilon and delta. Oh, nobody cares about this as an epsilon. You can keep this as a delta and keep this as an epsilon. You keep something else. Nobody's bothered about it actually. Nobody's bothering that you should keep an epsilon and delta. Just we want to have some other, you say this is lambda and this is mu. Nobody's bothered about it actually. Okay. So it means to say over here is that because we follow a standard, to talk about. So every book gives you the same notations, and these are the Greek numbers actually to away from the usual alphabets actually. So we are saying that the difference, the measure is very small as you're the measure. I mean, I can find a sufficiently interval over which, depending on this interval, I should find this interval corresponding to the domain of the function actually. There's nothing new in that, or not in a very complex scenario. is rewriting the given earlier studied definition. No, because measure is universal actually. Measure is universal. Am I right? Irrespective of what function you are taking now, this measure is universal. I'm trying to say that difference between the two functions or the two different two values, whatever you want to say, it should be, comes down to certain value we are saying actually. So this is the essence of your understanding of your epsilon delta function or the definition. But do not try to cook up too much. All the examples try to solve this problem actually. But the solving problems will give rise to me a geometrically understanding what is an epsilon and delta behaving like. We took some examples. Those are elementary examples actually. What we're trying to say, for that I need a limit, but doesn't gives you the limit as such, this definition, right? So you need another way to get a limit actually. So these are the only for understanding the definition, the problems that we have been given you to understand what is the epsilon delta behaving actually. So given an epsilon, you're trying to find a delta which is depending on epsilon. It is not the other way around, it is true actually. So these are all makes a sense when we are moving to the present course, which we're saying is a function of several variables actually. And your day-to-day life activities, functions of several variables are the real phenomena actually, right? So one-dimensional objects are, the higher dimensional objects are equivalent to the, you almost find a good number of scenarios, the multi-dimensional object you're sitting on it actually. So now I want to carry forward this definition to the multi-variable. So let's say, without loss of generality, let me say f is a function now from S to R. So this is the simplest situation I'm sitting with it actually. So where here my S is a, let your S is a subset of R2. This is a subset of R2. We call such a functions as a scalar valued functions. Call such a functions as a scalar valued functions. Because they takes a vector quantity but gives rise to me a scalar value, so we call that as a scalar valued function. Similarly, little later we're going to see vector valued functions also, but we start with the simplest scenario of the function. Like what we are trying to say is that we have a general notion, so it might maps to Rn to Rm actually. I hope everybody knows what is the Rn stands for is, because you already studied your R2. Am I right? You people have studied R2. That is a Cartesian coordinates, all the points of the form xy. And similarly, you might have studied also R3, which is your coordinate geometry or some other places here. So your R2 is nothing but your, which is actually, say congruent to your, of course, those who understand it's an R cross R actually. The geometrical representation that we make over here is that horizontal line and the vertical line to represent the points in R2. And this is congruent to your, don't worry about it, it's actually, so I want to have this is the cross product from your vector spaces, if you remember actually. Remember the cross product in a vectors, if you have studied it? This is your...
Yes, sir.
Yeah, so this is the same thing we're trying to say over here. So we have 3-dimensional x, y, and z. So any point over here is given by x, y, z actually. So the points in this is given by x, y. So we are trying to say that we move distance, let us say AB if I call it actually. So AB, then we move A as a positive, A is positive, we'll move this positive direction A units, and in Y positive direction B units, and the intersection of these two lines which I drawn it is known as your point AB. Similarly, it is going to happen actually. The point is the same thing you do it over here. So I'll find a cuboid. Actually, this point represents your XYZ there, or ABC. You want to take it up, you can take it up. So now we have the that. Now similarly, you can define what is an Rn and Rm actually. So we generally looking for this function. The simplest scenario that I'm going to set over here is that n is the least I can consider is 2 and m is 1. So this is one of the nicest and easiest way to understand the extend the results for the one variable that we studied it actually. Okay, later I'm going to see for different scenarios. Okay, first we'll start with the simplest scenario. So here is the one which I took it up. So never mind, or without loss of generality, many of the time I'll consider for extending the definitions or to give it, either it will be subset of an R2 or your subset of an R3. Never mind, only that in place of XY I'll be having an XYZ, nothing more than that. If I given in terms of xy, you should be positioned to extend it to xyz, or given an xyz, you should be in a position to answer them in xy. But that should be vice versa. Most probably will be sitting with these functions only. Behind this, you can extend it, not an issue at all. Now, let us define what is a function or limit means actually. Okay. For how do I define the limit for such a function actually? Limit of your scalar value functions. Okay. Say at a point, what we're trying to say is that we're saying that f of xy, when I approach it, it's tending to be a limit L actually. So because it is the outcome is a real number, and as your x and y is approaching to a point AB. So without loss of generality, let it be there. Never mind. AB. So what really is it any sensible to you? How do I really make, as I told you, in a given, it's okay, this is fine. How about your, this is your x, y, and we have a third, which is corresponding to the function. Now I'm trying to say that there is a point AB, and there is another point, we are saying some arbitrary point is reaching to this particular point in a domain, which is a R2, which is a domain for your function f actually. So what do you mean by approaching this point to this point actually? So is that definition is carry forward, one variable definition is carry forward over here or not actually? So the symbol doesn't make sense actually. But look at it. Is that epsilon delta definition can be carried forward over here? Take a moment and think about it. Is the epsilon delta definition can be put over here as a definition for your limit of function?
By keeping one variable constant, we can apply it for individually x and y.
But that doesn't make sense, right? You don't get a complete answer. So what are you trying to say that I'll move in x direction, but I neglect the y direction, and then fix the x direction and then move in the y direction. But that won't be giving rise to me the notion. And how do I approaching this particular point will be like, you moved in this way and you moved in this way. Could I say that way? How about this direction, and how about this approach? Why you're neglecting these approaches? Is these are meaningless for to reach to this particular point? Yeah, and double limit, that is what is done. So these lines are single lines are there. So I'm approaching along your x direction, and then I'm approaching. So you're saying that the function is you're saying that limit x tending to 0, y tending to 0, f of x comma y is equals to L, right? Sorry, x tending to A and y is tending to B actually. But what really is this is equivalent to say that x tending to A, y tending to B is equivalent to your xy is tending to AB? Will that be true?
Yes, sir.
Okay. So what it's trying to
Yes,
say
sir.
is that we the claim is that now what is that his approach is that now we want to find limit of xy is tending to AB f of xy is equals to limit x tending to A, limit y tending to B, f of xy. First you take with respect to y, and then you take with respect to x. And we're saying that this is also equals to limit y tending to B, limit x tending to a of xy. Am I right? That is what you're saying? Okay, so that's the claim of Ganesh. How many of you agree with this one? Okay, so I'm going to give a counterexample a little later. Never mind. So we have put this one. So this actually not equals to the case actually. So this is not equals to the scenario. It might happen in some cases, but it may not happen in all the cases. Okay, it might not happen on all the cases. So we have a counterexamples for that one. Never mind for that. Okay. So now moving ahead. So I'll give you the counterexample. So disprove it. One example is sufficient. Okay, remember, to disprove any claim, you give an example sufficient. But to prove that is true by example, you cannot do it actually. Okay, there's a point. Note that. So let me take now the definition of your limit. So how do I extend it actually? So this completely fails. Now how do I go ahead it? How do I define it properly? Because this particular quantity is wine, because this is once again a real number and this is a real number. This is making sense for me from the previous one. But this is a vector and approaching a vector actually. I'm not very clear actually. So how does this make sense actually? How do I go at it and to precisely make the point actually? See, your epsilon delta definition is a universal at the same time. What I mean by the universal is that measure is a universal actually. So you can measure in any, in particularly in any dimensions you can have a measure. So what is the measure in R2? I have a 2 points given in a, an R2 or R3. What is the distance between the 2 points actually? Subham Kumar is saying both iterated limits we use provided inside limit exist actually. No, okay, that is fine actually. The iterated limit, if this exists, I mean, that is what we're trying to say, that if this limits exist, iterative limits exist, then we're saying that is the limit of the function. I'm saying this is not equal actually in general. I will provide you a counter example. Never mind, don't worry about it actually. So at present, I do not carry that one. Definitely, we'll discuss. I'm going to provide this in the next class. So we'll look at this definition of your epsilon delta. That what we are having is that this can be carry forwarded because the underlying, this is a function of x, f of x comma y, and that's a real number. That's its range actually, and is also a real number. So this difference is making sense. Now what happens to the distance between the vector x and the vector a? So that's quantities. This is x comma y and this is an a comma b is less than. So what is this definition of measure? So we say that let your f is function from R2 to R. We say f has a limit. F has a limit L. Has a limit L for every epsilon greater than 0. The same thing I can write it over here. For every epsilon greater than 0, there exists delta greater than 0 such that your mod of f of x comma y minus L is less than epsilon whenever, this is a definition once again, mod of your x minus y to a minus b is less than delta. But to distinguish this modulus to this modulus, I'll just take 2 lines actually, nothing more, and do it. Okay, so I'll just take this to distinguish it, because this is an absolute value and this is not an absolute value, but what is this distance is. So this I take as an Euclidean distance actually. So the well-known, you can take any other distance also, but that needs another study. So, but presently I'll take as an Euclidean distance actually. What is an Euclidean distance between the 2 points? Which is nothing but your under root of x minus a whole square plus plus your y minus of b whole square less than delta, that we are trying to say it actually. Okay. So in one variable, do not get confused, or do not, always, be patient in understanding the underlying scenario. So what we are saying over here is that, so we have 2 lines, one corresponds to the x and another one corresponds to your f of x, and we have the distance between your this is the f of x minus L. So what really this means to say is that your f of x is less than or equals to L. L goes on other side, so we have an L plus epsilon, and then this is an L minus epsilon. This on expansion, what I get is that your x is less than your delta plus epsilon, delta plus a plus delta, whatever you say it actually, then you have a minus delta. So that means we have a small open interval around a point. Okay. X is tending to a, right? Yeah. So x is tending to a. So I'm looking for all those points within the interval actually. So this is means to say that deleted neighborhood, we call it actually. So we don't take a point A. So this is your a minus delta to a plus delta. So we considered an open interval in a on a 2 lines actually. So this is your L minus epsilon, and this is your L plus epsilon, right? This expansion of the modulus sign will give rise to me this thing. Am I right? And f of x is centered at between the point. Okay. So now what I'm doing is that this thing I'm carry forwarding. So this is in general we call as a, if you remember, I mean, if you've been taught this particular one, we call as a deleted neighborhood actually. Deleted neighborhood, NBHD, deleted neighborhood of the point A actually. So A is not there, and because that is the limit point that we're trying to say, it's away from A. What is the function behavior? If A is considered and the function value is going to be f of A, L is going to be an f of A, when I consider it within the domain, then we call that as to be as the function of the continuity. So in a limit, we talk about the function behavior except the point A. So I consider all the points in this open interval. So what is that we doing over here is that same thing as an extended over here. That open interval turns out to be a, what you can take this as a, what is this geometrically visualization is? Oh, what happened? I don't think so. You people doesn't know this thing. X minus a whole square plus y minus b whole square is less than or equals to delta square. What is the geometrical object associated with this one? Okay, it's a disk actually, because less than or equals to delta. So we have around a point. Now that open interval turned out to be an open disk actually. So we have, but that point will not be there. AB will not be there. And the radius of this is actually your delta. That's what we are looking for. All those points, this one. So that open interval reduces to be the disk actually, which is except that particular point. That is what we are looking for. So we usually put for a limit, the definition is the definition that we impose it. We want to avoid this particular point in a study. So we have x minus a, that's 0 greater than, means to say that we avoid that particular point to be not a part of the domain actually. Okay, similarly, we study in case of a limit, this is what is happening. Now we're trying to say that I look for all the points in this particular disk actually, for which I mean, this disk length or the radius of this disk, I'll find it out depending on the epsilon. And this makes sense for me because this distance should go to 0 by looking at all the points in this circle actually, or in this disk actually. So it is a universal extension, or you can take it to R3. R3, that is going to be a sphere of a, which is completely all the points within the sphere of a radius delta that I'm going to look at. And higher dimensions, we do not have a name as such, but that is how you can visual. I mean, you can think about it actually. So the visualization is, I don't know, we are having only up to 3-dimensional objects only. We can visualize it. Behind that, we do not have a particular way of naming it, or the visualization is not very thing, but that one can understand it actually. Okay. Got the point? So I can extend the epsilon delta definition to the that is a general notion that we're trying to say is there is nothing wrong that we do it. So because now we're trying to say that given this distance, you should find a this also we can call it as a neighborhood in your R2 basically. Okay, and this is a deleted neighborhood, means to say that AB is not a part of the domain of the function. It might have, the function may not be defined, but we're trying to find a limit for the function actually. So we say this is what is the definition can be carried forward. The same thing, we say a function is continuous. Let's say a function is continuous, same thing. Now we do not have this deleted neighborhood. Now we consider the point A as a part of the domain actually. Okay. So we say a function is continuous if your f is continuous, if it's your say R2 to R is continuous at your say x belongs to, sorry, at some point, say without loss of generality, I can take it as a 0, 0, or let be AB only. AB if the distance between these two values is actually less than epsilon. If given everything goes given epsilon greater than 0, there exists delta greater than 0, such that the above definition, everything goes there, such that your is less than delta. So whenever this is happening, that we can do it actually. So I'll take a couple of examples to make it to understand this one. Is it, first of all, you understood what is the definition over here? We cannot apply, once again, let me make it clear. You cannot solve the problems, all the problems using the definitions. Definition is for the understanding, or to prove some results, you can use the definition, but not every problem can be solved using definition. Fine? Agrees with me, everybody?
Yes, sir.
So once again, do not get confused yourself with respect to the definition. Definition is a universal way of giving you the precise what is happening, and you should get into another tools. The results are the one which we're going to say, which we state as a theorems actually. The theorems are the one which are going to help us to prove that thing actually. So that is why we establish some results which are useful in order to establish or verify the definition actually. So have a quick look at your textbook so that I won't be, because there is another issue I always faced with students is that as soon as my class is over, go back to your textbook, try to find the page numbers of that textbook where I'm looking, where I'm teaching it to you. That's your job. Do not expect me every time to, show you the page numbers of your textbook. And that's a 5 to 10 minute job. Either you take a help of your, form a group and try to, locate yourself that way. But for time being today, I'll be showing it to you, because most of the diagrams, which I cannot draw it, but your textbook has very nicely, drawn those diagrams actually. So visualization is very good. Visualization helps in many ways. Your remembrance will be grown very good. And at the same time, you'll find an enthusiasm in studying the things actually, or more understanding about the things will be there actually. Life is in your hands. How you visualize it, how you put forward in the doing the things, it will be goes on the same lines actually. So we have this particular chapter, limits and continuity, 14th chapter. Okay, so here is see that all nice diagrams are given to you. Explanation is pretty much, you just read it as a novel, and wherever you find a stressful scenario, you just stop there and take a little bit more time to understand this thing. So in the first part of this particular chapter, 14th chapter, he tries to give you more of, the functions of your multivariables actually, right? How do I go ahead it and how do I talk about, yeah. So functions of several variables, that's the chapter that we have it, a 14th chapter. This textbook I shared with you actually. So as I told you that, where do I come across? All sort of examples are given over here actually. The functions of, so what we do is that we look at functions of two variables. If required, I'll go with three variables also with the same understanding. So how that's, the function mapping and the domain blah, blah things are there. In R2, I take a points and that maps to the function. So we have another Z axis. That's a visualization. So visualization of, here the certain functions are there. And in a three-dimensional, if I want to visualize it, yeah, this is a definition of your, okay, now this is a domain for the function. And so these are the certain, yeah. So this is how it look like actually. So Z is equals to f of x comma y. Usually to visualize a one-dimensional object, I need another dimension. To visualize two-dimensional object, I need another dimension. To visualize three-dimensional object, I need a fourth dimension actually. So, okay. So this is how it goes in topology of the functions actually. So you have on xy plane, the domain is there, and that each point of the domain will give rise to me a function value of x comma z, and that is represented by x comma y comma z. Z is given by f of x comma y. You generate a surface actually. So that is a surface. But we do not get into too much of terminology. We call that as a function z of fx comma y, which is given as s and over the domain D. So here are a good number of examples for the functions that is given to you in the first part. You can quickly look at the first part. Okay. Sometimes it may not be easy to draw, but so there's a computer generated objects are there. And there are nowadays on your mobile phones also there are tools available actually. Graphical calculator. Two graphical calculators are there. Usually I follow this graphical calculator, GeoGebra. And you can install this on your mobile phone also. GeoGebra Classical 6 that I'm going to use it. And there are other tools are also available, which is for measuring and some other objects you can do it. So we have a 3D graphics over here. So for example, here is the function which has drawn whenever I do so on x square plus 3y square. So the same, you can, here, there is another graphical calculators also available, which is also pretty good, very popular also, Desmos. So these are the two things, but I completely stick to myself to this particular one. So we have 3y square times of exponential e to the power of your minus x square minus y square minus x square. It's very difficult to draw, but these computers, the graphical calculators exist. This is what is I can enlarge it. The geometry that you've seen in your textbook is only the part of it actually. So you can see it's a part of it. This is because you shrink it, you'll see that these bumps are there. These bumps are there. That's what you said. Okay. And I hope these are generated by some code actually or some other it's computer generated graphs actually of the several functions so that you can see it. These color combinations, you can change it actually. So this is how it looks like the sin x, sin y by xy actually. So I hope this visualization will come to be as a very good actually. Sin x times of sin y. I remove this one. Sin x times of sin y. Okay. Whole thing divided by xy. Okay. So, okay, it's almost not very good, right? You should see a bump there. Sin x, sin y by xy. Why I'm not getting like this then? This should come up, and I hope I'm unable to shrink it further so you can see that. Okay, so that is what up to 1 I taken the scale, so it's actually you can number of contours or something you can increase it, so visualize the exact graph actually, but most of the times I can use it actually. Like that's and there is a level curves or the level surfaces. This also you can read it out for time. I mean, I'm not getting into at this particular time, but we needed some time actually. So at different heights, so this is the three-dimensional object. So for different heights, what is going to happen to the counter that I get it for different values of k? Here the function is given you for, so this is for exact, we call that as a level surfaces that might be required for us the later stage. Okay, this is a projection of your sphere. The level curves for this one actually, so that is comes out to a different values k and x, right? You can read, yeah, this is what, when I projected on a contour map actually, so these are the stripes which is projected on the XY plane, this is what is the circles you're going to get it. These things are required for us in a later stage, but not at present actually. So do not get too much involved in that particular thing. You can move ahead actually. So this is how your the three-dimensional objects and the level surfaces that you can look at it. So it's the combination of spheres for different values of r's. I'm going to get it actually, radiuses. So visualization is very good. So what we have started with today is that I'm not getting into too much of defining the functions as such, but I hope with understanding of a one variable and just carry forward into the multivariables. So limits and continuity that you are going to study over here. So here are the couple of functions: sine of x square plus y square, pi x square plus y square, and x square minus y square by x square plus y square, as x and y is tending to near to the zero. Near to the zero, so approach from the y is approaching from the negative values as well as the positive values. X is approaching from the negative values. So we form a table. So similarly, we form a table at a point 0, 0. We do not know. Okay. So at a point 0, 0 at present we do not know. So what is going to happen? The limits for this function. So one can see that these numbers are approaching to 1, but these numbers are not approaching to any number, because in this direction it is coming to be 1, in this direction it is coming to be plus 1 actually. So this limit is 1, but whereas this limit is actually does not exist actually. Okay. That's how, but every time drawing this table is not that easy as we said it, but that doesn't also not precisely make a sense. So we look at the measure, and that's a deleted neighborhood over here, because in talking about a limit, so for every epsilon greater than 0, there exists a delta greater than 0, such that if xy belongs to the domain of the function AB, and then you can find a small circular area or the disk area except the point AB of radius delta, such that then your f of this distance between these two numbers is going to be less than epsilon actually. So other notion for the definition is that other notations for the limit of a definitions are this one as in told B, but careful about this understanding. This is not going to be not usually works, but this has to be understood as an iterated limit. So you have this is what we are trying to say. We can approach this particular point in multiple ways actually. So this notation is the one, but this notation has to be understood actually. Okay, but that notation is not the one we're trying to say is that x is approaching A, then I do it, and then see the y is approaching to A. That is not the usual way, because we have an approaches are the many ways, and this is what is the deleted neighborhood that has been drawn over here, and what is happening to the corresponding to the function actually. Okay, this d delta is the one which we have it, or what is happening to the function. This is going to be very small or not. That's what we're trying to see. I hope here you might have given the So what is happening over here is that this is can taken as a counter example. So as you're going in X direction, you'll get a one approach, one value, and going in along the Y direction, you will get another value actually. So in that particular way, limit doesn't exist actually. That is how I cannot conclude the limit exists for the problem. So here is also another problem. Yeah. Anyway, I'm going to see the problems in the next class actually. Don't worry about it. But read this particular chapter fourth in the beginning, what been said over here. Fine. We're going to see the problems in the next class. I'm going to talk about it a little bit later. A little bit more about it actually. Okay, prepare yourself. Read the textbook every day as soon as the class is over. Try to find it out the chapter numbers, the page numbers. Write it somewhere so it will be easy for you to read it later. Generally, we don't read every day. We do read it at the time of examination, right? So it should not confuse you which pages has to be read, because the description is very huge in this textbook. So we have to limit ourselves within the the contents that we are interested in. Not everything we are interested, like graphs of the functions of the domain of the functions. We are not studying over here, but we are interested in the definition. So note down those page numbers for your later references. Okay, I'll make a move because I have another class following this class. So we'll meet you in the next class. Move with which I'm interested to take questions from you. Fine. Bye.
Thank you, sir.
So the same way what I've done today, I'll be doing the same thing. I'm not putting your link. I'll do for 1 week to the Google Classroom. I'll put it there, as well as you'll receive a mail actually. If somebody missing a mail, please CR can take care of collecting those mail IDs, but I'm not going to update them unless until you update in the exam section. Okay, fine. Thank you. See you in the next class.
Thank you, sir.
Thank you, sir.
See you.
Thank
Bye.
you, sir.